Today we're going to be talking about slopes of lines. Okay, so the slope is the ratio of the change in the y-axis to the change in the x-axis. This is also called the rate of change. Rate of change. Okay, so the rate of change of a graph is its slope. So you have a rise over a run. So it's the change in y over the change in x. That little triangle symbol means delta, which is fancy for change. Okay, so you take your y2 minus y1 over x2 minus x1. How I remember that is you go up a certain amount of y's and over a certain amount of x's. I have to rise before I can run. Okay, classifying slopes. I look at this as like a ski slope. I don't like skiing. I didn't grow up skiing. But I look at it as like going up a mountain, coming down a mountain, or skiing, because I know a lot of us in the Bay Area here, we go skiing. So a positive slope is as you're reading your graph from left to right, up a ski slope. Okay? And then a negative slope, you're skiing down the slope. You're skiing down as you read from left to right. Zero slope is a horizontal line. Okay? Like think about the floor. You don't want your floor to have any slope. If it has a slope, then your furniture is going to go sliding. Or an undefined slope, I look at it as like a wall. You can't put your furniture on the wall. Okay, find the slope of each line. I'm going to be using, even though I give you a picture, I'm going to be using the formula, because a lot of times I'm going to be giving you guys I'm just going to giving you guys coordinates. Okay, so my slope here is the change in y. Look at this as your y2 function. So I have a -1 minus 7 over -1 plus a 3. And that turns into a -8 over a 2, which my slope ends up being -4. And yes, you could count that. Okay, rise over run. So I go down 1, 2, 3, 4, 5, 6, 7, 8. So I have a change of down 8. And then to get to t, I go over 2. So looking at the picture, that confirms it. But again, I want you guys to be able to use this formula. Okay, point F is at 6,2. G is at -2, -5. So my slope is -5 minus 2 over -5 minus 2. Make sure you're doing y over x. -2 minus 6. So I have a -7 over a -8, 7/8. Something else you want to make sure of is that this slope here, hey, that's a positive slope. My graph should be sloping upwards or going uphill as I read from left to right, and it is. And you can also count it out. I go, so rise, so I go up 1, 2, 3, 4, 5, 6, 7, and then over 8, 1, 2, 3, 4, 5, 6, 7, 8, and it checks out. Okay, find the slope of each line. So this one, okay, we have P that is at 0, 4, and we have Q that is at 0, -3. So the slope of that is -3 minus 4 over 0 minus 0. I have a -7 over a 0, that is undefined or no slope. I don't like the words no slope. Ignore that I said that. So that's an undefined slope. Here I have x is the point -2, -1. Y is the point 6, -1. So I have my change in my x, -1 minus a -1 over a 6 plus a 2. I have 0 over 8. This is a 0 slope. So again, the differences between these two. A wall has no slope versus when we have the floor, I should say it has an undefined slope. This has a 0 slope. Okay. All right, example 2. In 2000, the annual sales for manufacturing camping equipment was 48.9 million. In 2005, the annual sales was 85.9 million. Sales increase at the same rate, so they have, what they're telling you with this is that the slopes are the same. Okay, what would be the total sales in 2015? So, what you have there is they're giving you some points. The first thing you want to do is let x equal 0 be year 2000. I guess you don't really have to worry about that. It just makes the numbers a little bit smaller. So this, in 2000, 48.9, I have 0 and 48.9. In 2005, okay, so 5 years later, our sales were 85.9. So what you want to do is you want to find the slope of this line. Okay, so I want to do 85.9 minus 48.9. Yeah, y's over 5 minus 0 technically. I just didn't want to subtract it. I should show good algebra. That is 7.4. So this is my slope. So then if you want your slope to be the same when I have 2015, but I don't know what my sales are. Okay, so I have, find the slope between, I'm going to erase that because I want to do that in a different color, 15 and y. So we want our slope to be the same. We want our slope to be 7.4. Find the slope between this point, this 15 and y, and one of these other 2 points. I would recommend you pick this one just because it's a smaller number. Your x-coordinate is 0. So you have here y minus y2 minus y1 over 15 minus 0. See how that kind of makes that really nice? So I multiply both sides by 15 and I get 111. We add the 48.9 over. Okay. Okay. Okay, slopes of parallel lines. So if you have parallel lines, the slopes are equal. You think about it, they're never going to intersect. So if they're sloping at the same rate, they're never going to intersect. Slopes of perpendicular lines are opposite reciprocals. That's how I often think about it. Or you could look at it as being their product is 1. Okay, so we have a diagram here. We have 2 parallel lines. Both of their slopes are 4. And then we have our perpendicular line, which has a slope of -1/4. Okay, example 3. So let's find the slope. Determine whether FG and HJ are parallel, perpendicular, or neither. For those coordinates, graph each line to verify. Okay, so let's find the slope of FG. Okay, so FG. Y2 minus Y1 over X2 minus X1 slope of HJ is 3 minus 0 over 6 minus 5. So those slopes are neither, because they're neither the same nor opposite reciprocals. So let's kind of plot those so we can see. I have a 1 and negative 3 for point F. I'm going to label it just so I know what it is. Negative 2, negative 1. And I'm going to, normally I would want you guys to have a straight edge. I don't have a straight edge on here. So I'm going to try and graph that as best I can. And then HJ is 5, 0. And 6, 3, 6, 1, 2, 3. So that was J, this was H. Though they look like they're perpendicular, our algebra here told us they're not. Okay, example 4. Graph a line that contains Q, which is 5, 1, that is parallel to MN. Okay, so I have that is parallel, so it's the same slope. So let's find our slope of line MN. So I have a 1 minus a 4 over a 2 minus a negative 2. Okay, so the slope that contains this point has to have that same slope since I'm parallel. Okay, so I have the point 5, 1. And it has a slope of negative 3 over 4. Now, I want you guys to understand something about slope that I don't know if the Algebra 1 teachers are the best at. I was poor at it when I was an Algebra 1 teacher, but it's important when you get to Algebra 2 trig. So I can go up 3 and then left 4 because that gets me a negative slope. Or I could go down 3, right 4. So that negative sign, and again, you're going to use a straight edge here to connect those points. I don't have a straight edge on here, unfortunately. This negative sign can either go at the top and bottom. So you can go down 3, right 4, or to get the same slope, I went up 3, that's my positive piece of my slope. I now need to go negative 4. Okay, example 5. Graph a line that contains negative 3, 0, and is perpendicular. Okay, so my opposite reciprocal slope to CD. Okay, so let's find the slope of CD. So I have a 0 minus a 3 over a 2 minus a negative 2. So I have a 3/4. So my perpendicular slope is going to be negative 4/3. Okay, so I have the point negative 3, 0, and it has a slope of negative 4/3. So I can go up 4, left 3, or I could go down 4, okay? And eventually this is kind of getting us ready for what we're going to be doing tomorrow in our next lesson, where we're going to be actually writing equations of lines. Okay, that is all for today. Thank you for watching.